everyone, welcome to Vijay Chemistry. And today we are going to discuss the very important topic of our MS entrance exam. Sure, the one question will come based on this topic, that is called shielding effect or screening effect. Okay, then using the shielding effect, screening effect, we're going to find out what? The Slater rule. It means is that effective? Okay. Now first I'm going into using the atomic model. Okay, I'm going to demonstrate what is that effective. Okay, what is screening effect? Please note. This is nucleus. Okay, these are orbit, right? 1, 2, 3, 4, 5. Now, this is nucleus, a positive charge. This nucleus. This outermost electrons, they are inner electrons. Okay, they are inner electrons. Note. See, this is outermost electrons, outermost orbit. Okay, this is outermost. These are what? Inner electrons or inner shell. This outermost shell. Now we know very well what is it effective? What is it effective? Effective nuclear charge. What is it effective? The effective nuclear charge. Effective nuclear charge. Okay. What is the definition? See, the attraction between. Please note. The attraction between the nucleus and outermost electrons, right? And outermost electron. Now, which is outermost electron? This outermost electron, right? This outermost are going to attract by this nucleus. This is called is it effective, right? Now, this is what? Attraction effect. Okay, this is for attraction. You got the point? This is attraction. Okay, this is attraction. Please note. Now, what going to happen? Now, this inner electron, right? This electron negative charge, right? This all negative, both same charge are going to repel each other, right? This is reflection. This is repel. This is what? Electron repulsion. Please note. This is electron repulsion. Now, what going to happen? Now, okay, this electron and the electron repulsion going to decrease this electron plus this nucleus attraction. You got the point? Okay. Due to inner electron repulsion, what going to happen? Due to inner electron repulsion, okay, this electron not going to attract fully by the nucleus. This factor called shielding or screening effect. You got the point? Please note, due to electron repulsion, okay, the last electron, very important one, the last electron cannot be attracted by nucleus freely. Yes or no? Freely. Now, this decreasing force, this decreasing is force of attracting nucleus by attraction of nucleus by electrons are called screening effect. You got the point? Or shielding effect. Okay, screening effect we call SE. So please listen, and very simple, right? See, initially this electron, this nucleus going to attract, right? This is that effective. See, this term called is that effective. Now, is that effective going to decrease due to what? Due to this electron repulsion going to decrease this outermost electron, this nucleus repulsion. Okay. Now you generate the formula, very simple, right? Now is that effective? Now what is it effective? Effect nuclear charge depend upon what? Depend upon atomic number. Is that? Now this actually is not true, right? Because okay, some factor, which factor? The electron repulsion, they're going to decrease this outermost electron nucleus attraction, right? Therefore, what is the formula? The Z effective, okay, Z effective equal to, okay, atomic number minus S. What is S? Screening effect. You got the, what is the formula? Z minus S. Okay. Now what is Z? You know very well. What is Z? Z is atomic number. Z atomic number. Now what is S? That is called screening constant. Okay, screening constant. Now, so I know atomic numbers. For example, chlorine, atomic 17, sir. Scandium, atomic 21, sir. Then how to find out the screening constant, sir? Using the Slater rule, we are going to find out what? Yes. Okay, what is yes? The screening constant. Understand? Shall we go to the Slater rule? Please know. Very important, please know. Slater rule. Slater rule. Okay. Please note calculation of yes value. What is yes? Screening effect, right? Screening effect. Screening one. Screening effect. Now note. Okay. First step one. Please note. What is first step? Please note, very important. Firstly, write electronic configuration. Electronic configuration by alpha principle. By alpha rule. Okay, alpha rule. Second thing, very important one. Then arrange, very important point, please note. Then arrange, okay, electronic configuration. Electronic configuration in Slater manner. What is called Slater manner? I'm going to explain. In Slater manner. Slater manner. Listen, this is Slater manner, okay? See. What S orbital, listen, S orbital group, okay? P orbital group, D tani group, F tani group, okay? 1s, individual group. 2s, 2p, individual group, okay? And 3s and 3p, individual group. And 3d, okay? Separate group. Then 4s, 4p, one group. Then 4d, okay? Individual group. And 4f, individual group. You got the point. Upper oneness on the individual SP, okay. Other than more than one hour, will be single group. On the SMP is single group and DF on the individual group, okay. Understand? SMP same group, okay. Adhe oneness are the individual group. D orbital on the individual group. 4F on the individual group. You got the point? Okay. First, you have to arrange this manner, okay, of the right electronic configuration. Then going to find out the values, okay, separate value. For example, for n orbital, what is the value? Okay, now see, simple. Okay, now this is nucleus, right? 1, 2, 3, 4. Now see, this is outermost, right? Therefore, this is n. This is what? N minus 1. This is n minus 2. This is n minus 3. Okay, we have to separate the levels, energy levels, then apply the Slater rule. Okay, now see, very important, please note. And third important point, very important, please note. Third important point. Okay, then look for which electron S can be, what is S? Screening effect, right? Screening constant. S can be calculated. Positional mention பண்ணுவாங்க. Suppose if it is not mentioned, if not mentioned, okay, then find for lost electrons. You got the point? Question mention பண்ணிருந்தாங்கன்னா you can find out that electron. If not mentioned, you can find out the S value for the lost electrons. Okay. Now fourth one. Then follow contribution. Which contribution I'm going to explain now? Contribution in S per electrons. Okay. S per electron. That's not screening constant. Now see, simple one. Please note. I give you the table. This is very important table for exam point of view. See, simple one. Okay. Make a box. Now, see. Okay. Now, this is electrons. This electron group. This is electron group. Got the point? Okay. This is N. This is N minus 1. Okay. This is what? The greater than or equal to N minus 2. I mean, N minus 3, N minus 4 in the category. Okay. N minus 1 in the category. N minus 2 learned N minus 5 N minus 2 in the category. Okay. Now see. Oneness electron on this now. First one. Oneness electrons. Okay. Adora N value on the 0.35. 30. Oneness on N minus 1 N minus 2. Okay. Next. NS NPR in the NS NPR in Sabina. Okay. N value on the 0.35. N minus 1 value on the 0.85. N minus 2, N minus 3 1. We got the point. Other N D NFR in the Sabina. N value on the 0.35. Okay. N minus 1 on the 1. N minus 2, N minus 3 on the. Okay, this very important data. Please note, we put the star on this. Okay, this very, very, very important. Our exam point of view. Okay, we put the star. Very, very, very important. Okay, this is very, very important. Based on this data only, we can going to find. Okay, you can memorize. You can learn it. Learn this value before they enter the exam, because question without this value you cannot find out the Z effective, right? Because S is very important, right? Using this box only, we're going to find out what the S value. Understand? For oneness electron, N 0.30. N minus 1, N minus 2, there is no value. There is no meaningless. NS now only one electron will be there, right? 2 electron maximum. Okay. Then NS NPR N 0.35, N minus 1 0.85, N minus 2, N minus 6 1. NDF group N 0.35, N minus 1, N minus 2 N minus 2, N minus 3. More than N minus 2 or equal to N minus 2 or value 1. Okay. This only variation, right? Same one times. Okay. Shall I go to the problem discussion? Okay, now see the first question. Simplest question. First question. Okay. In hydrogen atom. In hydrogen atom. Okay. What is S value? We are going to find out. What is S value? Students, please note. Okay. In hydrogen, how many electrons? Configuration only one electrons. Only one electrons. Now we know very well how is it S value can be calculated due to what? Due to okay, this electron repulsion. Okay, based on this electron repulsion, okay, the Z effect can be decreases, right? This factor called screening effect, right? But in case of hydrogen, we have only one electron, right? Therefore, no electron repulsion. You got the point? No electron repulsion. Therefore, the S value equal to 0. You agree with me, right? Because there is no only one electron, right? One electron how to interact with other electrons? Only one electron. Therefore, there is no electron repulsion. The S value is equal to 0. Okay. Therefore, what is Z effective? Very equal to Z. So what is the value of Z effective for hydrogen atom? Answer is 1. Z effective. What is answer? Answer is 1. Simple. Answer is 1. They ask a simple question. Okay. Which are the following atoms? Okay, following elements having S value equal to 0. Which element? Hydrogen S value 0. So only one element, the screening should be at 0. Which element? It can be hydrogen. Okay. Second question. Okay. Second question. Now see. Very important. Okay. Find out. Is that effective? Is that effective of Cl? Nothing is mentioned, right? Therefore, we're going to calculate for last electron. We have to consider, okay, last electrons. Now, chlorine, what is atomic number? 17. Configuration 1s2 and 2s2 and 2p6 and 3s2 and 3p5. This is all for rule, right? We're going to arrange what? Slater mirror. What is Slater mirror? 1s2. You got the point? Now 2s and 2p, how many? 6 plus 2, 8 electrons. Now 3s and 3p, and the 7 electrons. You got the point? Now we're going to find out is X value. See students, very important. Okay, they are asking last electron. Therefore, we do not consider the last electrons. Okay, the last electron, English shell, English shell is okay, either attraction or right, either consider this is N, right? This outermost, right? This is N. This is N minus 1. This is N minus 2. What is outermost electron? In this case, 3p, right? Therefore, we're going to follow what? The 3p rule, which is 3p rule. This is a 3p rule. Because Ns, Np, right? Yes or no? Now we're going to apply the 3p rule. Okay, now how many electrons is N shell? Total 7 electron, but we're going to find out the last electron is S value, right? Therefore, you don't take last electrons. Then how many electrons here there? See, we can apply this one. See, simple. Now S value. Okay. Now how many electrons are there? Total 7. Last electron going to find, therefore 6. Understand? Therefore 6. What is N value for 3p subshell? N are the see what is N value? 0.35, right? 6 into 0.35. 0.35. You got the point? Plus this N minus 1. How many are 8 electron, right? What is N minus 1? See what is N minus 1? What is N minus 1 here? Okay, 0.85 into 0.85 plus Ns. What is Ns value here? 1, right? Therefore, 2 into 1. Now, what is S value? You can what is value? Should be around 10.90. What is the value? S value around 10.90. Now, what is Z effect? What is the formula? Z effect is equal to what? Z minus S. Okay, therefore, what is Z value for chlorine? 17 minus what is S value? 10.90. So what is the value? Is around the 6.10. You got the point? What is Z effective for Cl atom? 6.10. You got it? Okay. Now see. Third question. Very interesting, very important. Okay. Third question. For Cl minus, okay, take Cl plus. I'm going to find out what two configuration. Cl minus as well as Cl plus. C. What is Cl? So again 17, right? Cl. 1s2, then 2s2, and 2p6, and 3s2, and 3p5. Minus now 5 plus 1, 6. You got the point? Now arrange the Slater manner. What is Slater manner now? 1s2, then 2s, and 2p, 6 plus 2, 8. Then 3s and 3p and 6 plus 2 again 8. You got the point? Now they are asking last electron, right? Not mention anything, you can say last electron. Now apply the formula, simple. What is S value? This is N, right? This is N minus 1. This is N minus 2. You agree with me, right? Last electron, what 8 here? You're going to find last electron, you don't consider last electron, therefore 7. 7, what is N value? 0.35 plus 8 into 0.85 plus 2 into 1, right? Now what is S value? Is around 11.25. Then what is Z effective? Z effective equal to what? Equal to the 17 minus and 11.25. What is value Z effective? It can be Z effective equal to what? Equal to around 5.75. 5.75. Got it? For Cl plus, okay? Fourth question. See, very simple. Very interesting for going to see, okay? 17. Same atomic number chlorine, right? Configuration 1s2 and 2s2 and 2p6 and 3s2 and 3p, okay? 5 minus 1, that means 4. Okay? Now, plus now minus 1. Now arrange the Slater manner. 1s2, right? Now 2s and 2p 8, therefore, and 3s and 3p6. You got it? Now again, this is N, this is N minus 1, this is N minus 2. Okay, now S value. Okay, now this is going to last electron. Only you take 5, right? 5 electrons in 0.35 plus 8 into 0.85 plus 2 into 1. Now what is S value? Is around what? Is around the 10.4555, 10.55. Got it? Now what is Z effective? Okay, the 17 minus the 10.55. What is the value? Around 6.45. Okay. Now we look the interesting fact. See, in case of CL, what is the value? 6.10. Understand? Okay. See, for CL, is that effective value? What is the value? 6. What is the value CL? 6.10. 6.10. For CL plus, what is the value? CL plus, what is the value? 5.75. Yes or no? For CL minus, what is the value? Around 6.45. Now you know what is it? Is that effective? The attraction between what? The nucleus and outermost orbital, right? Due to is that effective? What going to happen? The size can be decreases. You got the point. Now tell me which one has have the more, okay? Which one has have the more what? More is that effective? See. Sorry, CL plus on the 6 point. Sorry, ma. CL plus thanita. What is CL plus value? 6.45. 6.45. What is CL minus value? 5.75. Okay, now what is that effective now? The attraction between nucleus and outermost orbital, right? The more is that effective, the size can be decreased. Now that tell me, this is A, this is A, this is B, this is C. Which is more is that effective? Tell me which is more is that effective? CL plus, right? Then followed by CL. Then CL minus. Now what is size? We know very well size inverse order is that effective, right? Is that effective increases and size decreases. Therefore, what is size order? CL minus and CL and CL plus. Understand? That's why people say what? Some people say, okay, most of people say the atom, same atom, have negative charge, the bigger size. The same atom or positive charge, the smaller size. The neutral in between, right? This is based on what? Is that effective value? Okay, using Slater rule, we can find out what? Which is higher size, which is lower size. This is very interesting fact. Okay, and final question, I'm going to discuss one example for what? D orbitals. Okay, please note. Question number 5. Question number 5. For scandium. Okay, atomic number 21. I'm going to find out what? The last electron. Last electron in scandium. What is last electron? That means 21st electrons. You got the point? Now see the configuration. Scandium 21s2 and 2s2 and 2p6. Okay, and 3s2 and 3p6. Okay, and 3d1 and 4s2. Listen, actually, okay, this is for 21st electrons. You got the point? Because, okay, this s orbital first fill, then go for d orbital, right? But this is our rule. Understand? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. Understand? First 4s electron, firstly filled, then go forward 3d electron. Okay, they asking 21st electron. What is the last electron now? The 21st electron, right? Now arrange the Slater manner. Simple. 1s, 2, then 2s and 2p8, then 3s and 3p8. Okay, then 3d1, then 4s2. Okay, listen, we are going to find out only what? We are going to find out this 3 orbital, right? Therefore, we don't consider 4s. You got the point? Very interesting, very important. Please note. Okay, they are asking 21st electron. This is a 21st electron. Okay, this is Slater arrangement. Okay, first S, Pe, upon Pe, D, 3D, upon 4s. See, this is arrangement. Okay, see, this arrangement. 4D is for least compared to 3D. Okay, this is Slater manner. Okay, you have to first write the 3D, then followed by what? 4s. Okay, then followed by 4s. We got the point. Okay, then this is a 21st electron in what? Scandium, right? This is a 21st electron. Therefore, the 4s cannot be counted out in this method. Okay, understand? Now see, very important. This point, please note. Okay, they are asking the 21st electrons. Which is 21st electron? Is 3d orbital. Okay, according to Slater rule. Okay, first you have to arrange 3d, then go for 4s. Adala vandu 1s, 2s 2p, 3s 3p, 3d upon the 4s. This is 21st electron. Therefore, this 4s electron, 2 electron don't contribute in what? To calculate the s value. Okay, now find out the values. This is n. Okay, this is n minus 1. This is n minus 2. This also n minus 2, n minus 3, right? Okay, now what is S value? What is outermost? 3D, right? We have to follow 3D rule. Which is 3D rule? See, a 3D rule, right? For ND, okay? For N, 0.85, matala 1 simple. But this is for 0.85, right? This N, 1 electron. Listen, we are going to find out only our last electron, right? Yes or no? Therefore, you in the electron, there is no electron. Put 0. 0 into 0.35. You got the point, because we're going to find only last electron. Consider only one electron, 3 is sufficient. Therefore, I put 0 plus then 3 plus 8 electron, right? 8 into, okay, 1 plus again 8 into 1 plus 2 into 1. Because in case of D rule, what is the only contribution? N is 0.35, n minus 1 is 1, n minus 2, n minus 3 is 1. Okay, now apply the formula. What is the value for S value? Is around what? Is around 18. Is around 18. Then what is it? Is that effective? The Z effective that equal to what? Equal to 21 minus 18. Therefore, Z effective is equal to value is around 3. Okay. Now very interesting fact, ma. Okay, try to find out this Z effective value. Question number 6. I give the homework. Okay. Is that effective for? Is that effective of for 4s electrons in scandium? Okay. Now you're going to consider this electron. Please understand. Okay. You have to mention all the electron. Okay. This value, please note. Is that effective value? Is around what? Is around 18. Is around 18. If you do the calculation. See, interesting fact. Okay. In case of scandium, what is 3D or is that effective? 3D ko 18 da, 4s ko 18 da, right? 4s ko 18 da varum. This is not the same. How will be same? It's not possible, right? Therefore, this is what? One of the demerit of Slater rule. Please note. Please, very, very important, ma. The both and 3D and 4s orbital electrons have same S value. Okay. It is not possible, right? Therefore, this is the demerit of Slater rule. Okay. Now do this question. Okay. For Z effective for 4s electron, apply pani paranga. Sure, you will get Z effective of 18 only. Okay. So it's not Z effective, sorry, ma. S value is 18. Z 18 okay. S value can be 18 da varum. Okay, S value 18. S value 18. S value 18. They have the same S value. Okay, same S value and the same Z effective but you will get right because 3D subshell vera 4S subshell vera. Okay, this one of the demerit for what? Demerit of Slater rule. Now, this is very, very, very important for MS entrance exam. Hyderabad University la kandipa questions kettirukanga. Adhe mari Pondicherry la kettirukanga. CUSET la kettirukanga. Okay, Delhi la kettirukanga. Okay, they are very, very important topic our MS entrance exam. I hope you understand the Slater rule and spinning constant. Thank you so much for watching and see you in the studio as soon as possible. And tata, bye bye. Take care.